ever been to a construction site? Or even come across one in movies? You might have noticed frames made of steel, steel meshes and steel rods all around. And once the construction work is completed, only a concrete structure can be seen, no steel rods. So, what purpose do these steel rods serve here? Concrete on its own does not make a good structural material. This is why steel is embedded in concrete to provide more resistance to the outside forces. This is called reinforced concrete. Solid mechanics is an area of study which specializes in the behavior of materials, especially solids, when exposed to stress. Elasticity of a solid can be described as the resistance of a solid material against the deforming force and the rate at which a given solid sample regains its original shape or size after deformation. To understand why solids show the property of elasticity, we must dive deep into the molecular arrangement of these solids. In a solid, each neighboring atom or molecule are bonded together by an intermolecular force, so that these molecules stay at their equilibrium positions. Now, when an external deforming force is applied, these atoms or molecules get displaced from their equilibrium positions. In other words, we can say that the intermolecular distance between two neighboring molecules will change. If the force exceeds the bond strength, there is failure. But if the force is removed before failure, these molecules will come back to their original positions. This mechanism can be visualized better with the help of the spring ball model. In this model, balls represents atom as you can see here and springs represent the interatomic bonds. Here, when an external deforming force is applied, the force displaces the balls from their equilibrium positions, but the spring pulls the balls back to their initial positions. In the beginning, we have discussed about the concrete reinforcement. To make the concrete structure highly resistant to external stress, steel is incorporated into the concrete. Why steel? It is because the elasticity of steel is very high, meaning steel has a very high ability to resist the deforming force. The term elasticity in physics is not synonymous with the normal term that we use every day. To give a quick example, consider a rubber string and a steel string of equal dimensions, meaning same length, width and thickness. Try to stretch both the strings. Which string stretches more? Obviously, the one made of rubber. This implies that steel is more difficult to stretch. That is, steel is more resistant to the deforming force. Hence, steel is more elastic compared to rubber, which is against our intuition. In conclusion, we can say steel is more elastic whereas rubber is more flexible. Okay, so we have already established that elasticity is the resistance against external stress. But what exactly is stress? Do all materials experience the same kind of stress? Or do materials experience a combination of different kinds of stresses? Let us summarize what we have learned so far.
Manorama Horizon. Learning made simple.